I'm Carl Bauman from US Shift. I'd like to introduce you to Jake Chandler, who you've probably spoken with in the past.
I've been with the company since 2015. That was my second stint. And my first one was back in 98 to 02, I think. When I first started, it was Bauman Engineering back in those days. And came back in 2015 after it was US Shift. And basically, I'm the guy that responds to all your email inquiries. And you might talk to me on the phone if Kevin is tied up. Anyway, this is my car, the 2006 Mustang GT that we're doing the 10R80 swap on. And a brief history about it. I purchased it in January of 2024. I had a Coyote car that I sold and really wanted to get back into the 05 up body style. And this car came up. It was a really good deal. It was a high mileage car. And obviously I wasn't concerned about the transmission given that I work here. So I did kind of luck out though in that the 5R55 that was in the car was actually a good one. I did enjoy driving it for a little over a year before we got cracking away on the 10R80. It's a simple bolt-on car, cold air raid intake, custom tune, just a mail order tune at this point, but that might be changing. Actually, that's changing as we speak. And full exhaust. The car actually does have aftermarket exhaust from the headers all the way out to the exhaust tips. So it sounds good and it runs strong for what it is. Starting up front, we did go with the BBK tuned length headers, just because we already had, the motor kind of up and out of its cradle for the transmission, and we figured why not? It's an extra bit of power and better sound. It's a good quality product. So the BBK headers, we decided to go with an off-road X-pipe design, right now due to fitment issues. If you run the stock catalytic converters, you will have clearance problems with the bell housing. So this was a good solution, for now, but before we go out on the public highways, obviously we'll do everything in compliance with the EPA. We also went ahead and, again, because the engine was sort of up and out of the mounts for the swap, we went with BMR motor mounts, the polyurethane. So it's a nice cross between solid mounts, and it does have a little bit of cushioning and flex. So it's not a nightmare of a ride or teeth chattering. That actually, I could tell a big difference on our drive earlier. The car feels a lot more solid.
And they make a difference too, and they let you adjust the height of the engine too.
Yeah, which we think we inadvertently did because all of a sudden the car handles a lot better. So we may have dropped the motor a little bit. And then you may be able to see the DEI wrap on the cooler lines and on a lot of the wiring. We really like that stuff. I mean, they're good guys. They were next to us at SEMA. We got to meet them, and that's a really good product. Some of you might be familiar with it. Beyond that, obviously, you can see here's the 10R and factory OEM mount and bracket, factory shifter. So in my opinion, it looks clean. The car looks like it came this way, except for the exhaust. I want to make sure and point out that we do have the original 331 rear axle ratio that came in the car. We really thought that was going to be too much given the 4.17, 4.18?
No, 4.7.
4.7, I'm sorry. First gear ratio of the 10R80, but surprisingly it's not. It's not. The car, does fine in first gear with this 331. And it makes sense because the newer Mustangs that come with the 10R80 from the factory, we looked it up and they actually have 331 standard. So it makes sense when you drive the car, but on paper we thought it might be too much, but it's not. And then just finishing up the exhaust, we just have good aftermarket SR Performance mufflers. And other than that, as you can see, it's a pretty simple setup.
As Jake mentioned previously, this swap has a lot of appeal because these cars came with a not so great transmission from the factory, and they're actually, pretty inexpensive on the market now. And the 3-valve motor has a lot of potential The transmission was a big bottleneck in these cars, unfortunately, in the factory ECU tuning. And the torque reduction to save that smaller 5R55S transmission was also an issue. But another nice feature of this is this S197 basically later got the Coyote and the 6R80, and this is a factory S197 6R80 crossmember bracket, and the mount is also the same thing, and these parts are bolt-in. The 10R80 was really designed to be kind of a drop-in replacement for the 6R80 across all the vehicle lines, so the pad location is the same. The flange is about an inch further back, inch and a 16th as far as I've measured. You know, it bolts in as if it came with the vehicle. And S550 is a little different because it's independent rear suspension. The back portion of the drive shaft is different. It's longer to accommodate the IRS. But this is a 2011 to 2014 Coyote 6R80 drive shaft, and just had our drive shaft shop cut an inch and a 16th off the front section, and it fits like a glove. So it works just like it did. You could also fabricate an aluminum drive, one-piece drive shaft if you so chose. You have to take about an inch off of it. I would recommend putting the transmission in first to get exact measurements, so before you order that drive shaft, because the angles may come into play and affect the measurement. And we also had bought a 2018 drive shaft, but the back section is different because of the IRS. I'm not sure if Ford changed the sheet metal and the floor pan over the S197 run or even into S550, but there's plenty of room. The transmission fits really nicely in the tunnel, lots of space. But most of this literally is factory parts. We come over here. This is a shift cable bracket for a 2018 up 10R80 Mustang. Bolts right on. The cable is from the same application, 2018 up 10R80 Mustang. The shift lever is different because we actually used a shifter out of a 2011 to 2014, well actually really 2013-14 Coyote 6R80 car. The reason we did that is because we wanted to add the upshift downshift manual button to it. 2011 and 12 cars don't have that feature, but the 2013 and 14 do have that, and we wanted to add that easy way to add manual shifting to the car. But that shifter was designed for a 6R80, and that has 7 positions, so the sweep is about, close to 90 degrees on the shift lever. That's divided up by 7 positions in a 6R80. In a 10R80, it's 5 positions because you don't have the PRND and then S for sport or M for manual. So what we decided to do was we're going to fabricate a lever to get the right length. That means the lever needs to be shorter than it would be in a stock 10R80 car with the stock 10R80 shifter. And we were about to do that, but we had a lever from a 2021 to 23 F-150 with E-Shift. Those transmissions have the feature where you don't have a shift cable. You've got basically a park override lever. This becomes a lever to let you move the vehicle if the transmission just totally goes kaput. And then everything's electronically, the ranges are electronically shifted, park, reverse, neutral, drive. So we had one of those override levers laying around from another transmission, and I said, well, that's shorter, let's try that. And we tried that lever, and it was a perfect fit. The ratio of the linkage is ideal. It shifts just like a factory car, works perfectly. So I wonder if maybe somewhere in Ford, during development, they had developed a lever to do that. It's possible, and then the E-Shift lever is based on that. The E-Shift lever also had a little extra appendage on it where you could push it in the park override position, put a bolt in this boss, and lock it out of park. And I cut that lever off, or that extra little boss off that lever, because it would potentially interfere with this boss on the case. So I just cut that down and make it a straight lever where it wouldn't hit. This is another 2022 Mustang 10R80, similar to the one that's in Jake's car. I wanted to point out something. This is where the shift lever goes. The 2018 cable, as I mentioned, is shorter, and it takes an S-shaped path from the shifter down to the transmission. And there's a plastic bracket with like a Christmas tree style fastener on it that fastens to the transmission right here. And there's like the Christmas tree fastener, and there's just a boss here, a plastic boss that goes in this hole. So you essentially snap that down onto here, and then it retains the cable and creates the proper geometry for the cable. And it works perfectly even in the older car. But do not wait until you get the transmission in the car to put that in, because you can put it in the car, and I did, but it's much easier to put it in on the transmission before you lift the transmission in the car. You just have to protect the cable while you're lifting the transmission up. In the cooler lines, we used our DEI wrap, as Jake mentioned. These are Aero-Clip push connect fittings, socketless fittings, which are a little hard to get on, but they're good. And that is a power by the hour adapter to get us to AN fittings. These are 8 AN lines, or ½ inch essentially, which is what you need for a 6R or a 10R transmission. And then we fabricated these brackets, use these holes in the bottom of the bell housing to allow the cooler lines to cross over from one side to the other. And we're going to refine this design a little bit and probably make it in stainless steel and make it available. It's a little bit tight, so we're going to add a little more room to it, but yeah, we'll make these available because I believe all the V8 10R80s have these holes in them. So this is a really convenient way to get your cooler lines across and secure them. It's really solid, and that should work well. So as we come up to the front of the vehicle, you can see the cooler lines coming up here, and we had to have a cooler with ½ inch fittings or 8 AN fittings because these transmissions need that size line. The 3/8 is not adequate. The original transmission actually did have ½ inch lines, and it did have a ½ inch cooler. We've been using the S550 cooler normally, which is a good fit for a lot of things, but the bottom line is the radiator is already set up to accept the factory cooler, and it works perfectly. It should be plenty adequate. It's big enough. So we decided to retain that. OEM replacements are no longer available, so we bought an aftermarket one and installed it and just ran our lines right to that, and it worked perfectly. This is the S550 cooler used from 2015 to 2023, and it works well in a lot of the swaps. It fits pretty well and is pretty compact. This is the original 2005 through 2010 cooler that came on this car. It's appropriate for all early S197s, and it worked fine and already had a ½ inch line, so we used a new version of this. So for the shifter, we wanted to add this Manutronic plus minus manual shifting button for sport mode, and we didn't want to get into having to add paddles to the steering wheel, so we thought this was a good compromise. The original shifter wasn't in great shape anyway, and the 2015 up S550 shifter would have been totally different in the console area, and that console would be very difficult to adapt. So we decided this was a great compromise. This bezel on the shifter goes on much like the original one did, and this shifter has exactly the same mounting points as the original one to the floor pan, so the bolt holes and the studs all line up. Everything is good there. The front of the shifter opening lines up the same, and the width is the same, and the bezel is just a little bit longer, and this goes back a little bit further. We had to carve out a portion of the console, as you'll see, of the actual console, and the cover plate, the bezel, this piece here, we had to cut out to match the bezel and let it fit in properly. And now it fits like a factory application. The only clue is that the bezel is really close to the cup holder, but many people probably wouldn't even notice that. Sometimes when you get into a project like this, you discover other things that are wrong that need to be fixed too. And that's what happened here. This is the main fuse and relay box, referred to in the service manual as the bus electrical center. And essentially there's a feed coming right off the battery that feeds everything power. And it goes to all these fuses and relays, and there's 4 connectors coming out of the bottom, which each of these screws goes to the respective connector to hold it in place. And this is like the main power distribution point for the car, and feeds the smart junction box, which is the fuse box inside the car, as well as other things. So the ECU in these cars, which is right here, does not provide a tact signal. You can get it over the CAN bus, and we're going to do that shortly. We're actually adding CAN bus functionality to our controllers this year. We have the place for the hardware. We just have to develop the firmware for it, and that was one of our next projects. But for now, we have to get the tact manually with a tact adapter. So we had to take this apart and find the 2 wires that feed both banks of coils in the engine. You break that wire, you insert this tact adapter in the circuit. It's got a red wire and a red with a green stripe, and the red goes to power and the red with green goes to the coils. And then you've got a ground and a signal out, and the ground we ground to our controller's ground, so everything's in the same ground. And the signal out is gray, which hooks to our yellow tact wire, and boom, we've now got a tact signal. So we took all this apart to do that, and upon taking apart, we discovered the low-speed fan terminals that feed the low-speed fan circuit that terminal was pretty much melted into the plastic, and it's just a matter of time before there was a bad failure, no fan, or possibly, major damage from the heat. So we, in the process, rerouted the fans. We cut the fan wiring out of the connectors going to this, and ran into these 2 40-amp relays here, which we still have to screw down. And so those are there. And then we have a new feed coming right off the battery terminal of the fuse block. And we have a fuse holder there, and it uses the same exact fuse that was in there. We pulled the fuse out, which I think was here, put it in this fuse holder, and then crimp spliced it with our good crimp splices to these 2 relays that feed the original fan wires. The original fan wires go here. The original trigger wires that turned on these 2 relays that used to be here go directly to these relays. So we put a weather pack connector in the middle of it in case we ever have to take the engine out of the car. We can break that and pull the harness apart like it would normally come apart. But we can cover the details of that in a wiring sheet if anybody's interested, because that is a systemic problem with these cars apparently. It's usually the low fan speed circuit, not the high, because the high only turns on when it's really, really hot. And the low speed can run for hours if you're stuck in traffic. And I think this car might have come out of Atlanta, so it probably got baked pretty well down there in traffic. But everything else here stayed the same. And we ran our power wire for the controller right to one of the circuits in here. The same circuit it was on, but it was only 20 gauge wire coming off of the splice, so we ran our 16 gauge power wire right to the output of the fuse that feeds that. And it's also on with the oxygen sensor heaters, the intake manifold runner control, the secondary throttles, and also the cam phasers. They're all on that same fuse. So we went right to the source here, so we get a low impedance, good power source for our controller. And then as for the ground, we had to redo all the slip loom because the original slip loom in this car was all pretty much crispy and gone. So we re-slip loomed everything and ran our wiring in with it in the process. And the ground comes around here, and this is the point. This is called G102, ground 102 in the Ford diagram, and this is the ground for the actual engine control computer, and our ground here is right on the same post, so it's a very close, well connected path, because you want to be on the same ground as the ECU if you're sharing a sensor like a TPS or an APP, because we need that ground reference to be the same between the two. That's a critical thing. Did something a little bit different on the ground wire for this controller. Since it's a little bit longer, we, instead of running a bigger wire, we ran 3 small wires. three 18 gauge wires in parallel. And that actually creates a lower impedance, low inductance path. It's actually, we found out that 3 small wires is actually bigger than one 14 gauge wire because the inductance is lower. And sometimes that actually matters more than the resistance. So this is the best possible way to wire it. We'll cover that in the future too and add that to our manuals. So we're always learning and improving and making things better. That's our goal. We don't want to stay in the same place. We always want to make things better and improved. But another point to mention is this, Nyogel 760. It's a synthetic connector grease, and you say, what is connector grease, and won't grease make connectors not conduct as well? This actually fights fretting corrosion because the connectors move around as the car is driving and moving, and there's micro vibrations, and when the contacts move away from each other in a connector, then that opens up basically bare metal for corrosion, and that metal will oxidize almost immediately. So that where the pins were touching, you get a layer of oxide, and then the connector moves back and it goes back to where it was, and then the part where it most recently was gets oxidized. So it ends up with a layer of goo of like black oxide building up, and the connector resistance slowly increases over time. So when you have grease on there, and dielectric grease would probably work, but this is actually the best stuff to use. You can buy it on Amazon, Nyogel 760, made by Nye Lubricants. This product essentially, contacts cut through the grease, so the grease is not inhibiting contact, but the grease coats the pin so it inhibits corrosion. So as the pin moves around, which it always will do, it prevents corrosion. If Ford had put this on these connectors going to the electric fan, this problem would have never happened, because I'm sure the pin on this bus electrical center was actually rated for 40 amps, which is what the fuse size was, but with years of fretting corrosion, heat, and moisture, it will derate itself and not be good for the full load anymore. So when we put it back together, we put this on every pin coming out of this to prevent problems. And we did that in the smart junction box too, because that is a problem area as well. And you'll see in the pictures, those connectors were starting to turn a little bit green, but they weren't damaged yet. So all those pins got this stuff. These cars have a tendency to leak water into the kick panel area, so watch out for that. You want to make sure that you don't have the water leak, which is mainly the cowl drains not draining properly. Half the firewall is covered by cowl, which makes it hard to run wires into the car too. But yeah, you want to make sure those drains are clear and that you don't have any water leaks, because that bus electrical center gets taken out by bad water leaks sometimes, and you need to make sure that's protected. Jake already fixed that in this car, and we put Nyogel on all the pins, so hopefully everything will be fine there. We had to tap into there to get the backup light wire off of the smart junction box, because normally when you put the original transmission in reverse, manual or automatic, the engine computer knows that, the PCM says, okay, we're in reverse, then it sends a CAN message to the instrument cluster and says we're in reverse, and then that sends out a message in the medium speed or low speed CAN bus to the smart junction box, which says, hey, turn on the backup lights. So it seems a little bit complicated, but that's how it works. And none of that was really possible now, so we cut those 2 wires for the backup lights off the smart junction box and splice them to our backup light output, and it works perfectly now. So we'll cover that in our wiring sheet too as well. So anyway, yeah, these relays now control the fans, and it works just like it did. It just won't melt down anymore because these are good sealed relays. And we also use Nyogel on Quick 6 and Quick 10. All the pins that carry a lot of current for the solenoids, power, ground, all get Nyogel. And that should be on every Quick 6 or 10 installation to prevent problems with fretting corrosion. So we're a big believer in this stuff, and it definitely works. This is a 470W Flexplate that you might have seen in some of the previous videos. This came out of the Grand Marquis before the 10-speed went in, and it actually has the small bolt circle pattern for the smaller 470W converter that was used on 4 valves and some 2 valves, and that car originally had that. But this was kind of our baseline. It's the 164 tooth standard Ford. Back spacing from the back of the crankshaft is like 785 thousandths, I believe. And this is the 5R55 Flexplate that came off this Mustang. It's essentially very similar. The back spacing is actually slightly more. The converter sits back to the back of the car, probably 40 thousandths more than the standard. The 470W 6R80, C4, FMX, AOD, all those had the same back spacing. So all those traditional Ford transmissions in the 6R80 are the same. E4OD and C6 have a bigger back spacing, so the converter's pushed back more in the front of the vehicle. The 5R55S is just slightly pushed back, but it has this extra rim on it for some reason. But you know, we have to use a 10-speed 10R80 Flexplate. And one of the things they did with the 10R80 is they changed the starter to make it crank the engine faster because of engine start-stop, I believe. And you'll notice the Flexplate teeth, the overall diameter of the ring gear is the same, but the teeth are larger than the 164, and I think there's 141 of them, I believe. So you can't use this with an older starter. You have to use the 10R80 starter, which actually has a different bolt pattern. Unlike all the other modelers that have 3, this has 2 bolts, but not like an old Ford starter. We covered that in the Silver Bullet series. But anyway, this is the correct Flexplate, but as you might remember from the Silver Bullet series, this only works on an 8-bolt crankshaft. This is from a 5-liter truck with a 10R80, or a Mustang with a 10R80, or an EcoBoost 3.5 or 2.7. They all use the same Flexplate. So we kind of had to cobble something together in the Grand Marquis, which we'll replace when we upgrade the engine later. I convinced our friends at Suncoast to make us a prototype. They make a beautiful billet Flexplate for the 10R80, an 8-bolt configuration. I said, can you make one with 6 bolt holes? And they said, sure. And this is the prototype. It looks a little rough because it's been sitting around, but we're finally putting in this car, and we verified the fitment. The backspace is the same. This is about 685, I think. It's 90. Don't quote me on those numbers, but this is about 90 thousandths closer to the engine than the older transmissions are. They were trying to save every little bit of space with the 10R80 to make it fit where a 6R80 fit, and they grabbed 90 thousandths from the Flexplate area by pushing the converter forward more. So this is about 90 thousandths closer if you measure this distance to the crankshaft face, about 90 thousandths of an inch less than these older Flexplates. And the Suncoast, of course, has the same back spacing, and I believe it's SFI approved, so it's safe for big power and, you know, certain drag racing classes where that's required. Of course, it does have the correct tooth pattern and pitch, so this is a nice bolt-on and upgrade, and a safety upgrade too. So definitely a good piece, and it makes this swap possible. One other thing to mention that changes too is the block plate or spacer plate, whatever you want to call it. You notice there's only 2 holes for the starter because it's the newer starter. And one interesting thing, it goes in like this, obviously, on the front of the transmission, and the Flexplate would sit like this, of course, and the converter studs go through the front of the Flexplate. Well, there's a TSB for like 2018, 2019, and maybe 2020 F-150s, I can't remember what years you covered, for a clanging or clattering sound on startup, or at times. Well, apparently under certain conditions the end of the converter studs will hit this plate, will hit the block plate, because they push the converter forward. There's a little bit of extra length in the studs. So, and my Grand Marquis actually did that, and it still does it sometimes. When you start it up, you hear the studs hitting the block plate. Hopefully it's not hurting anything, but it's really only during cranking, because once the engine's running and the pump is making fluid pressure and pressurizing the converter shoves the crankshaft forward against the thrust bearings. But during startup, there's no well pressure in the engine, there's no pressure in the converter pushing the converter forward, and the crankshaft is free to wobble backwards and forwards, and if it has some play in it, it's going to hit this plate. So Ford came out with a revised version. You notice they didn't change it much. They had a little notch here, which is apparently enough of a relief, and they added this little smiley face shaped groove, which is right in the bolt circle of the studs, so that they'll hopefully clear. I think what was happening was, due to thermal expansion, maybe the plate would wander back towards the engine more, or wander back towards the transmission more and get in the way of the studs, certain hot and cold conditions. So that's just an interesting aside. If you're doing a 10R80 swap and you don't have the smiley face one, which has the engineering number JL3EBB on it, they all have the same basic part number, 6A373, but the BB is what you want. This one is an AB, or AC rather, so it should end in BB. Please note the service part number for these plates is different than the one that's actually stamped on the plate. The service part number actually is JL3Z7007C for the one you want, the updated one, and it's JL3Z7007A for the old version. So just make sure the one you buy has the suffix C. Just think C is correct. I'm not sure why the hitting of the studs on the separator plate only happens during the startup, but in my experience it only does. It could be due to the engine not having oil pressure yet, and the crankshaft being able to wallow around in the engine more than it does once the bearings are oiled. I'm not totally sure of that, because counterintuitively, during startup there's no pressure on the converter, and after the engine starts, the converter gets pressurized by the pump, and that actually wants to push the converter out of the engine, out of the transmission, because the pressurization happens through the sleeve at the back of the converter and acts like a piston and loads the crankshaft. And that brings up another point that's interesting about transmissions is, if you have a converter that balloons, it will expand or push on the crankshaft excessively, and that'll damage the thrust bearings in the crank, and you'll have to take the engine apart and replace the main bearings. So that's something to be careful for. And when you put the transmission in the car, no matter what kind of transmission it is, make sure the converter is not pressing against the flex plate. There should be a little bit of space between the front plane of the converter and the flex plate. So when you put the nuts on the studs, or on a GM application, put the bolts through the plate on the converter into the holes in the converter, it should pull the converter slightly forward. If you're pushing the converter into the engine with the bell housing bolts when you put it in, something is wrong, and it's going to probably destroy the transmission. If you don't have the converter in all the way, when you take the converter out, you have to make sure everything is engaged. You've got the input shaft spline, you've got the stator spline, and in some cases like the AOD, you've got another input shaft spline. But you got to make sure that's all properly engaged and the converter set back all the way into the transmission, and there's actually a little bit of space, probably about a 1/16 inch roughly, between the converter and the flex plate. If you don't have that, you're going to possibly destroy the front pump, or in this case, the stator support. The front pump, the pump's actually down in the valve body area. And you could wreck your engine too. You could wreck your thrust bearings. So that's something to be cautious of as well.
All right, Carl, so what do you think now that we finally finished the car and I actually got to drive it for the first time, about an hour ago? And obviously I'm really excited right now. It may not show up on camera, but I'm just thrilled with the way that it turned out. What are your thoughts on it?
No, I'm very happy. The transmission's working very good. Everything's there. We've discovered a few more issues. That was one of the benefits of having this car in the stable.
Yeah.
We get a few more issues worked out before it goes out to customers to make sure it's perfect.
Right.
We're not doing our testing on one or two vehicles, so that's an important thing. So we're happy with how the transmission's working. We still have a few engine tune issues to deal with. These 05 up computers are a little bit picky about removing the automatic transmission, and we're trying to deal with that the best way we can. So.
Is it safe to say, do you agree right now at this stage that the majority of the issues that we're having are not related to our system or the actual transmission swap? It's primarily the engine tuning.
I'm perfectly happy with how the transmission's working. It couldn't be better, honestly.
It feels great.
No, yeah. As far as the transmission side, we're very happy. We just have to get some fault codes out of the ECU and get it out of limp mode. And, we're probably down, what would you say, 20% on power right now? So.
Yeah, I mean, clearly, my guess is the intake runner controls are not opening up, or it's losing a bunch of timing. That's what it feels like, because the motor runs perfectly and smoothly. It just literally is down on power. So
yeah, these PowerPC ECUs don't like having the transmission pulled out from it. So
yeah,
we may even have to go to a manual ECU, but we'll provide a later video where we'll update all those details and explain what we did. And we're trying every avenue to see the best way for our customers to make things work right. So that's an important thing. We want to provide you all with the easiest steps to accomplish this swap in the most efficient way.
And I can tell you this, the first thing that you're going to notice, assuming you do everything correctly and follow our instructions, the first thing that I noticed driving it today for the first time, as soon as we pulled out of the driveway here at the shop, took a left, I looked down at the remote display and we were in 9th gear.
Yeah,
it was shocking to me, having never really driven something like this. I'm embarrassed to say. I mean, I support these things all day long, but I haven't spent a lot of time in anything other than our development vehicles here at the shop. Not a lot of time spent in customer vehicles, and I've never actually owned anything with one of our products on it, but I never even felt it shift at part throttle.
Well, that's the funny thing. You take off at like 10 or 15% throttle, and before you know it, you're going 50 miles an hour in 9th gear.
Yeah.
And you're not even accelerating hard. It just happens. And
it was amazing. And the other amazing part was feeling it step down, at 50 miles an hour, and giving it a lot of throttle. It felt awesome. I mean, it would drop down into the appropriate gear. And
I can tell you for a fact that I put a lot of time into downshift scheduling, downshift handling, as far as, what gear you can go into from previous gear. And
right.
The downshifts are now self-tuning, which we're adding to all of our products.
Yeah.
Forward. We're gonna retrofit everything we've learned from Quick10 back into Quick6.
Exactly.
So the 6R80 will have all these benefits too. Right now, downshifts on Quick6 do not self-tune, but we're going to fix that pretty soon.
And that's something for all of our existing, 6R80 customers to look forward to. If you've got a Quick6, there are going to be improvements down the road.
Oh, yeah. There are certain gears that you can downshift to in one step, and other ones require 2 steps.
Right.
Any gear from 7th or below, you can go from 7th gear down to anything below 7th in 1 step, which is great.
Yeah.
So we're going to have a mode where you can turn off overdrive and basically be 1 through 7. And if you mash the throttle, you end up in 4th gear, 1st gear, whatever it needs. It'll go there.
Yeah, the more gears you have, the more options you have for stuff like that.
Oh, yeah. And 8, 9, 10, you're a little limited in what you can downshift to, but we've actually improved the downshift where you can get right to the lowest gear possible.
Yeah.
It's actually possible to downshift from 10th gear to 2nd gear. And you wouldn't think that would ever really happen, but we've actually in the data log, I have a scenario where I did that driving.
And it doesn't knock your teeth out?
No, it doesn't. Yeah, there's self-tunings. They really improve as you go, you know.
I wish we had an opportunity to have done that today. I can't wait for that scenario.
No, it's nice, yeah. If you're slowing down, coasting in 10th gear to the point where it's about to downshift out of 10th gear.
Yeah.
And you're down to like 30-something miles an hour, where if you step in the gas at all, it would go out of 10th gear. But if you mat the throttle, it'll go to 2nd.
That's awesome.
Yeah, so I love this transmission. I mean, it has capabilities that are beyond belief.
Do they do that in OEM applications? 10th to 2nd? Or is that an us thing?
It might be an us thing. I don't know.
That sounds like an us feature.
But basically, if you can get there by turning one clutch on, you can do it in a single step. But if you have to turn on 2 clutches,
okay,
instead of just one, then you can't really do it in one step and have it work right. So,
well, one thing I forgot to mention, getting back to this particular car, first and foremost, it's important, I just have to say, we're concentrating on the 05 to 09 Mustang because that's what this is. But obviously, the Quick10 standalone system, it'll work.
Oh,
this is designed so that you can put the 10R80 in any vehicle you want. It's just
yeah, we're actually, our intent is to be able to put a 10R80 in anything that has 4 wheels.
right.
That's literally because we're actually working with Josh at Performance Adapters.
Yeah.
He's developing a lot of new adapters that'll let the 10-speeds go to all kinds of different engines. So,
and we're already talking to a lot of you folks out there that have small block Fords, big block Fords, already going together with a 10R80 behind it.
We've got a beta tester who has a 4.8 LS, and he's getting ready to turbocharge. So
yeah, Chevy people are not excluded from this.
no, and we're doing the GM version soon, the 10L90 and 10L80.
But for right now, they'd have to use an adapter simply between the 10R and the LS. Okay.
You'll need an adapter for small. The bolt pattern between LT and LS is very similar.
Okay.
There's a top bolt they moved and a few other changes, so you can't really bolt an LT transmission right up to an LS. So Josh is going to work on an adapter for that soon, hopefully.
Okay.
And small block Chevy to LS, it's still a similar bolt pattern, but not everything lines up. And he's going to work on an adapter for that. Well, the big difference between LS, LT, and traditional small block Chevy is the crankshaft protrudes out about 3/8 of an inch.
Okay.
On a small block Chevy, whereas an LS is flush like a Ford.
Gotcha.
So that we're working on adapters for all that stuff. So you can use the GM transmission behind the GM engine. There are some minor changes with the GM versions of the 10-speed, and we're addressing that. That's coming up soon. We have a 99 Trans Am that we're going to swap a 10L90 or 10L80 into.
Okay, nice. I wasn't sure if we were going to do the 6L or the 10L, so okay.
We've actually, we were planning to do the 6L80 for years, 6L80-90, but the problem with that is it has the Bosch controller.
That's right.
And we have been planning for years to bypass that, but we've done the math.
There's no easy way to do it or cost effective for the customer.
Yeah, it can be done, but they'd have to basically cut out the TCU and solder in a wiring harness, or we'd have to provide a solenoid body with a wiring harness that they put in, which is going to tremendously inflate the cost.
Right.
And the bottom line is, and if y'all have a different opinion than we do, please let us know and we'll change the plans. But
yeah, let us know.
Right now, we feel like the added labor and expense, because you can't just put a 6L80 and you've got to get rid of that controller, and that's going to be additional expense and cost. So you could just put a 10L90 in your car and
right.
Be turnkey and
have four more gears.
Yeah, so
without having to remove the pan and perform valve body modification.
Yeah, as long as you've got a good low mileage transmission, you could just stick it in there and wire up our controller. So
that does make sense. And if you're dead set on having a 6-speed automatic behind a GM engine, there are adapters for this Ford 6R80.
Oh yeah, yeah.
So
That's true too. Yeah.
that's even more of a reason for us not to go down that Fix L path. We really hope that you enjoyed this look at my 2006 Mustang GT. Again, just to kind of wrap up, the primary reason we chose this vehicle, I'll admit when I bought it, I wasn't necessarily thinking 10R80 swap, but it worked out. And when we began thinking about it and taking measurements, we quickly realized that even though this is an 06, underneath the car and the chassis is essentially very similar to the newer models that do come with either 6R80 or 10R80. So it fit like a glove. We realized quickly we could make it look like the car came this way. Plus we knew it was going to increase performance significantly. So we hope you enjoyed it. Just keep an eye out on our channel. We've got a drive video that should be coming up really soon. Like Carl was saying, the only thing we're sort of fighting with is some ECU tuning stuff. We've got some really good friends in the industry that are helping us with that. It's just admittedly, because we focus on transmissions all the time, Carl and I don't have any experience with ECU tuning. So
slowly gaining it, but the 06 computer is not a great place to start.
Right, and the only reason we don't have a drive video for you right now is we're just not happy with the performance of the car. To be honest with you, we know that there's a lot more left in it, so we want you to see it at its full potential.
In fact, when there's more in it, we might have to do something with the rear tires and axle ratio, but we'll address that when the time comes.
Right, yeah, we're not sure if these tires are going to last when this motor is doing what it's supposed to do. So
there's a distinct possibility they may not. Yeah.
But on top of that, we've got other projects in the works. So, if you did watch this video all the way to the end, we really appreciate it. And we're going to be doing more stuff like this in the near future.